Hi everyone, it's Mr. H here, and today's lesson is on the surface area and volume of cones. If you are in my applied math class, we're actually only looking at the volume of cones, so you don't need to know that. So the applied, we'll just look at volume, and that section, the section you're looking at would be section 3.2. 3.2 would be the applied section for that. So you can, if you're in the applied class, you can skip over the surface area and focus on the volume. First though, let's look at what the definition of a cone is. A cone is a 3D object with a circular base and a curved lateral surface. So this curved surface around the outside, all the way around the outside like this, is called the lateral surface. It extends from the base all the way up to a single vertex right there. Now, as far as the surface area is concerned, if you were to unroll this whole cone and see what it looked like as far as the net, we call the unrolling of any 3D object the net of it, what you would find is you would find something that looks like this. You would find a piece like that, and you would also have the base, which is a circle. And so the surface area of a cone is given by pi r squared, there's the circle, plus pi rs. Remember, s is the lateral surface height, so it's the distance from here all the way up to here. So it's also the distance on the net from here to here. So you have pi times r, the radius, times s, plus that area of the circle. So pi rs takes into account this part of it, and then pi r squared takes into account the circle part of it. So this first example says find the surface area of the cone below. The surface area of a cone is pi rs plus pi r squared. We know what s is, so we can just plug these values in. So pi times 8 times 17 plus pi times 8 squared. And so it's just going to end up being 628.32 centimeters squared when you multiply that out. Remember to use the actual pi button in your calculator. And also remember to square the 8 if you didn't get the same answers I did. It would be good to pause it, type that in your calculator, and just make sure you get the same answer before you move on. So really that's all there is to it as far as surface area. I do want to point out though, occasionally you might be given this value. Let's say this is 15 centimeters. And if you didn't know what that is, you would have to use the Pythagorean theorem to solve for what that lateral surface height is. If you're just given the height of the triangle, that's not good enough to find the surface area of the cone. So it's just worth noting that. In this case, you have enough information to solve it directly, but if that was the case, you would have to use the Pythagorean theorem. All right, let's talk about the volume now. The volume of a cone is calculated as follows. The volume of a cone is 1/3 pi r squared times the height. So before we actually calculate this next question for the volume of the cone, I want us to look at the bottom of the page and see this about the cylinder here. So the volume of a cylinder is pi r squared h. And what I want us to think about is if I was to fill up a cone with water and dump it into a cylinder that had the same height and the same radius, how many times would that volume of water fit into that cylinder? And so if you actually click on the link below in the description of this video, you can see a video where an individual does that and see if your prediction is correct. Now some of you are making a connection here between the equations as well. And if you are, that's really great because that's really the connection I want you to start to see. I'm just going to scroll down here so that they're both in the area that we can see. We've got the volume of a cylinder. We've got the volume of a cone. And the only difference between these two equations is that one says 1/3 and the other one doesn't have 1/3. And so, again, you can watch the video to see it for sure, but if you think about it, if I have 1/3 of something else, that means I can fit it 3 times in the other volume. And that's exactly the case. The volume of a cone is 1/3 that of a cylinder that has the same height and the same radius. Let's get back to this particular question where it says find the volume of the cone above. So let's have a look at that cone above. And remember that we need to know the radius. We know the radius, but we also need to know the height, and we don't yet know the height. So what we have to do is we have to use the Pythagorean theorem to find this height. Now notice this is like the A side, this is like the B side, and then the C is always the hypotenuse. So the height that we're trying to find is not the sum of the other two squared. we have to set up the Pythagorean theorem and rearrange it to find the height. So let's label these on the, I'm just going to take this triangle right here, and I'm going to label those on the triangle down here on the right. So we have 17 centimeters, we have 8 centimeters, and we want to know the height. And so as I said, if this is your A side, and this is your B side, and this is your C side, we've got C squared equals A squared plus B squared. And we know that C is 17. So 17 squared is equal to 8 squared plus the height squared. And so to solve this for the height, I have to square 17. And squaring 17 gets me 289. And I have to square 8. That gets me 64. And then I just subtract 64 from both sides. And that gets me a value of 225. And then that would give me h squared is 225. So if I take the square root of both sides, then I get a height of 15. Which works out quite nicely here. So the height of this particular cone is 15. So this, now we have the height, and now I can solve this. So 1/3 times pi times the radius, which we said was 8 squared, and then the height is 15. And that gives me a volume of 1005.31 centimeters. And the units of volume are cubed. Up above in that example that we did, we had centimeters squared because that was surface area. But for the volume of a cone, it's centimeters cubed. So there's an example of both the volume and the surface area of a cone. I want to talk very briefly now about the volume and the surface area of a cylinder. If we had, as I noted earlier, the same height and the same radius of a cylinder, we could have just put in the radius and the height. We could have put in a radius of 8, we square it, and a height of 15, multiply it by the radius squared and pi, we could have found the volume of a cylinder. But just as a way of review, you've probably seen this in grade 7 and 8. If you unroll a cylinder, so let me just get that cone out of the way so it doesn't look like the cones what we're doing. If you unroll the cylinder, what you're going to get is you're going to get a circle on each end, and you're going to get this big long rectangle, and the distance along this rectangle is the circumference of the circle, because that, remember, that rectangle has to wrap all the way around the circle in order to get there. So there, that's the circumference. So that's why we have 2 pi r squareds, because this is the area of the circle. So we get pi r squared there and pi r squared here. Having some trouble here. There we go. So we've got 2 pi r squared, so that's this part of the equation. And then you have 2 pi r times the h. Well, what is 2 pi r? That is the circumference. And the height is this. So if you take the circumference, this distance along here, and multiply it by the height, you're taking the length times the width of that rectangle. And so that entire equation together represents those 2 circles plus the side. So keep in mind, if you're asked a question where you're just finding the side surface area of a cylinder, you don't want to include the 2 circles, the 2 pi r squared part. Or if there's no top and there's a bottom, you only want to include pi r squared and not multiply it by 2. So keep those in mind as you go and do these different questions. And as always, if you have any questions, feel free to ask for help. Love to help.